Okay, so now we would replace the double dots with single dots because this is the data cleaning part. Okay, so replace THE equals to quotation single dot if THE double equals to quotation double dot. You will see 485 real changes made, right? It's easy to clean it now, right? If the variable names are short. So replace water equals to quotation single dot if water double equals to quotation double dot quotation closed. 302 real changes made, right? Replace POW equals to quotation single dot if POW double equals to quotation double dot. So 496 real changes made. So if you go back, you will see all the double dots are, for THE is replaced by single dots. Okay, I went to browse and checked it, that whether it's working or not. So similarly, replace POM equals to quotation single dot quotation closed if POM double equals to quotation double dot quotation closed. So let's go and check POM now. POMs, all the double dots are replaced with single dots. That means the missing values are being replaced by the single dots. Okay. So replace PFS equals to quotation single dot if PFS double equals to quotation double dot quotation closed. Right. So what it is doing is basically it's replacing all the double dots. So the PFS, the double dots are the missing values, and Stata cannot read the missing values. So we have to replace it with single dots. Okay, then we will do destringing. So replace PMS equals to the single dot if PMS double equals to double dot quotation close. Now last class Anna asked me why we use double equals to for the second part, right? So what Stata is doing is double equals to in Stata means it's an equality sign. So if the data set contains the double dots, then it's only replacing it with a single dot. Okay, so double equals to means it's like a equality. So Stata is looking that if that is equals to that, right? So I have replaced almost for all of them. So the last portion with a single dot if FRT double equals to double dot. So I have replaced for all my 7 variables. Now I need to make them dstring for all the variables. So what I do is dstring FRT and then you write gen means generate, and you have to give a different name. I am naming it as FRT1. You cannot give the same name because it won't replace that variable. It will generate a new variable. So click it.
Why we dstring again?
Dstring because it's in string form, right? Stata only can run numeric numbers. So if it's in string form, it's thinking that those are characters. But we need to dstring it to so that Stata can run it. Stata doesn't understand like if it's string or like a numeric value or flow. So let's look at the FRT. And once you dstring it, if you observe, see it's now highlighted in black. So when it's highlighted in black or blue, Stata can recognize it and run it. So after destringing, the FRT1 now is black, and the original FRT, which is the fertility rate, was in red, right? It was in string form, but after destringing, now it has become like a double. If you look at the type, see there is a variable. Look at the type. It's now double, right? It's no longer string. But if you click on the FRT, previously the type is str5. which is in string form. But now FRT1 is in double form. So I just distring one variable, we need to distring all the variables. So distring FRT as FRT1, PMS, gen, PMS1. And you always have to give a different name. So I distring the PMS, I will distring the PFS, okay, and you can use page up to get back the previous comments. I will distring POM as POM1, I will distring the POW as POW1. Okay, I am using page up to get the previous command in my Stata command prompt. Distring water as water1, okay, and only left with the total health expenditure, THE as THE1, right? So now let's go to browse. All my numeric values have been distringed, okay. The missing values are already replaced with missing values, since in 2007 they didn't have any smoking variable, so they didn't create any. So it's consistent. Just I'm checking the 2010 just in case, because they have the smoking variables. If they are present, we have to check they are present. And when you actually distring it, if you go to 2010 or anything, if you look at this figure, they will distring it as the nearest one decimal place, okay, because if you look on the board, it's 60, POW is 64.09, right? But once we distring, it has become 64.1, so it will distring to one decimal place. So there is some sort of inefficiency with the distringing, okay. You also have to mention that in your paper, that we have distring the variables, but there could be like a minor inefficiency, because it converts to the nearest one decimal place. It doesn't capture all the 10 decimals, okay, but that inefficiency is less than 1%, to be honest, okay. Okay, what about the year variables, the country name? These two we have to do encode, okay. We cannot distring them because these are already in string format. So you should write encode. Let's click on the year variable and generate bracket year 1, encode country name, okay, generate country, or country 1, let's just name it country 1. Only these two variables you cannot distring. So if you see, they are now highlighted in blue, the year and the country 1, year 1 and country 1, okay. Only the year and countries you have to use encode function, okay. Is that clear to everyone? Country name, you can click on the variable. You can either type or you can click. Clicking is easier, yeah. Over year as year 1, yeah, again.
It's a country name, right?
Country name, yeah. You can either type it, but it's best to actually click on, double click on the variable. That way you won't make any mistakes. Okay. So basically the steps that we have followed so far is similar for cross-sectional data, right? We can do a cross-section also, like if we just want to analyze 2007, right? So the same steps you follow for cross-section. Okay, so now once we have said this, Now let's go back to the do file that I have uploaded. Okay, so go to your do file in the Dropbox folder. Okay, click econometrics 2. Right.
Wait, is it the one that you edited like 8 minutes ago? It's like econometrics 2 IPO.
Yes. Open that. Go to your Dropbox sharing. Click on that folder, chapter 2 webcast. It should be there. You got it? Open that. Okay. So once we have a panel, okay. So how to set the panel? We first have to, if we go back to our file, which has the data set, right? Go back to our file, our data set portion. You first have to write xt set and then country 1, year 1. Okay, this is the command. So xt set country 1 and then year 1. You should put the country first. Yes. If you run that command, so xtset means it's setting it as panel. Right? What do you see? It's saying that country 1, the panel variable is unbalanced. Okay, maybe it's unbalanced because we have the lower number of observations. Right? But we can still run a panel data. Okay? And then so I am writing some comments. So after we set the panel data, what we have to do is we need to run the regression as fixed fx first. Okay, so I'm just writing a comment. Go to the do file that I just given. Type xtreg. Our model is total health expenditure is the dependent variable. So xtreg the. It should be the1. Sorry, all the ones. Yes. And the independent variables are water1, POW1, POM1, PFS1, PMS1, FRT1. Right? Let me see how many. 1, 2, 3, 4, 5, 6, 7. Then comma FE. Okay, this is the command. Look at the screen. xtreg. I will write it in big so you guys don't make any mistake. It should be xtreg the. First one should be always the dependent variable. Then the remaining 6 independent variables, which are FRT1, THE1 by the way, because I have the new variable which I destringed it. FRT1, POM1, etc. Then comma, once you write all the 6 variables, comma, fixed effect, FE. In fact, small FE. Alright? Yes, comma, then fixed effect. Right, all the 1 variables. Yes. Yeah, the comma should be later. Yeah, after all, if you written all the Okay, so we are running a feature. Yes, 7 variables, right? Yeah. Okay. All of you have written that. Amna, you have written it. Where is it? Yes. Just press enter right now. So what it will do is it will run the data set as a panel data. Okay, now we got the coefficients of water, POW1, POM1. If you go to R square, in a panel, now the R square, there is different type. There is within R square, between R square, and overall R square. It's not like a cross section. For a cross section, you only have one R square, right? When you do a panel, you will see there are three types, like within, between, and overall. Alright? So this is one difference. But we do not know whether we should use fixed effect or whether we should use random effect. Okay? So just go and write EST store FE. So we are storing the fixed effect. EST means estimated store fixed effect. So EST store FE. Okay? Let me write it down here. EST store FE. What it does is it's storing the fixed effect. Okay? Then press enter. If you go down, you will see that there is an estimated fixed effect which is captured in our variable list once you store it. Right? And before actually going there, how many of the variables are significant in our data set? Look at the p-value. If the p-value is less than 0.05, how many of them are there?
Only one is water.
Only water is significant, right? And maybe the constant term. But constant term is of no interest to us. We don't know what it is, right? Okay. So now go to the command prompt. Click page up twice. Once, twice. Instead of fixed effect, now write RE. We change the FE as RE. So go to the command prompt. Go page up again. Yes, instead of FE, run it as a RE, random effect. Okay, you ran it already? Okay. Yes, RE. Already. Nice. You did a random effect as well? Whatever you write. Okay. Good. You run it, Michael. Now, after running it, we also have to write it EST store RE. So now we are storing the random effect. EST store RE. Okay, store it first. EST store RE, EST store RE, good. Okay, perfect. In the random effect, okay, in the random effect, which variable is significant? In the new model. How many of them are significant in the random effect? If the p-value is less than 3 of them are significant, 2 of the variables and 1 constant, right? So p-value is less than 0.05 is for prevalence of female smoking and prevalence of male smoking. So ideally we would love to have the random effect model, right? But which model should we use? That can be only explained by the Hofmann test. You cannot say that, oh, I got the smoking variable significant, so I will use random effect. No, there is a procedure. Like even though you like the random effect model, we have to check the Hofmann test. Okay, Hofmann test will tell you whether you should take the fixed effect or the random effect. You do not choose just because you can write a nice paper on it, because because the smoking variables are significant. Okay, so for Hofmann test, in the command prompt, write Hofmann, HAUSMAN. Let me check my do file if I'm yes. Then you write FERE, comma sigma more. Okay, this is just a comment. Go to my do file. Okay, the do file I uploaded. Okay, let me just put it on the screen like in Paint, so it will be easier to. Okay, do not execute the command yet. This is the command you guys should write. Hofmann, FERE, then comma sigma more. What it is doing is the thing that we have stored in the fixed effect and random effect. Now Hofmann test will confirm which model to run. So you have to type this in the Stata command. Okay, and now let's press enter. So the p value is greater than 0.05. Okay, and the chi-square value is 11. It's bigger, right? So if it is bigger, then open the file that the PowerPoint file. Okay, over there, if you go to the so if p value is, if you look at the PowerPoint file, if the chi-square value is big, that means we reject the null and fixed effect model is appropriate, right? When p value is less than 0.05. But for our case, what is the p value? So we do not reject the null, and random effect would be the perfect model in our case. And it's actually very nice. And now you can write a paper on smoking using this effect. Okay, so you guys, if you go to my slides, slide number 11, okay, it talks about the Hofmann hypothesis test, right? But our p-value is greater than 0.05. So we cannot reject, and that's why we have to use the random effect. And the random effect model is nice because we got both the smoking variables as significant, right? Which is the second one. So now just do xtreg THE1, in fact, page up, run the random effect. And now look at the coefficients. So for females, if they are smoking more, that's increasing their health expenditure. But for male, it's not increasing their health expenditure, but in fact, it's decreasing it by a little bit, 0.03. Can you go up? Okay, so that's the idea of panel. Let me just pause the video and let